12.1 Vectors in the Plane, Part 1. Imagine a raft drifting down a river carried by the current. The speed and direction of the raft at each point may be represented by an arrow. The length of the arrow represents the speed of the raft at that point. Longer arrows correspond to greater speeds. The orientation of the arrow gives the direction in which the raft is headed at that point. The arrows at A and C have the same length and direction, indicating the raft has the same speed and heading. The arrow at B is shorter and points to the left of the raft, indicating the raft slows down as it nears the rock. Let's talk about notation. Vector PQ has tail P and head Q. We also say vectors are equal if they have the same length and direction. So vector A and vector C are equal. Let v sub a represent the velocity of a plane relative to the air in which it travels. Then the magnitude of v sub a is the plane's air speed, which is the speed the plane would have in still air. Let w represent the velocity of the wind. Then W points in the direction of the crosswind. The length of W represents the speed of the crosswind. The combined effect of the motion of the plane and the wind is the velocity of the plane relative to the ground, v sub g. Let's do some more vector addition. 3u plus 2v. Start with 3u. At the head of 3u, put the vector 2v. The result will be the vector OR. Three v minus w. Start with 3v. At the head of 3v, put the vector minus w. The result will be the vector OQ. It is easiest if we can write a vector in component form. If the vector v is written v sub 1, v sub 2, what that means is that v travels a horizontal distance of v1 and a vertical distance of v2. Its magnitude is therefore quite easy to find using the Pythagorean theorem. If the horizontal component of v, v1, is equal to x2 minus x1, and if the vertical component of v, that is v2, is equal to y2 minus y1, then the vectors v and pq are equal. Given the points O, P, Q, Find the components of OP and PQ. Also, find their magnitudes. Let's start with OP. What is the horizontal and vertical component? The horizontal component starting at O and ending at P, the horizontal component is -3 minus 0, or -3. The vertical component is 4 minus 0, or just 4. The magnitude is 5. Now let's look at PQ. It's easy to see from the graph what the vertical and horizontal components are, but let's do it out algebraically also. So starting at P and going towards Q, it's 2 minus a -3 and 5 minus 4, confirming a horizontal component of 5 and a vertical component of 1 that we were expecting. The magnitude of PQ is equal to the square root of 26. This slide has a typo. Where it says magnitude of OP, it should say magnitude of PQ. And that concludes part 1, vectors in the plane, and I'll see you in part 2.